Hello everyone. Hey, good afternoon, good morning, good evening. So welcome to the SecApps learning. So today in this video we will be discussing about the network security, which is a subset of the cyber security. So the cyber security is a vast subject which includes various technologies such as the SIM, endpoint, firewalls, vulnerability management, identity and access management, the risk management, penetration testing, application testing, and so on. The list is there's a big list there. So all this which includes the cyber security. So basically today we will be discussing more into the network security. As I said, it's a subset of the cyber security. So in this video, we will be discussing the network security and its basics, and we will be focusing on to the Palo Alto firewall. So how exactly it will works, and so how the market is about the how the market is on the Palo Alto, and then we will be discussing how will be the carrier the carrier goal in the network security, and especially into the Palo Alto. Okay, so let's move on to the basic topics which will be covered today. Yeah. So 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 this is the basic topics which will be covered today. So and this is the most basic things which ideally anyone should know, or when they want to move their career into the network part, the network security part. Okay, so today in this video I will be mainly concentrating on the basics, how the communication will be happening between the two networks, two computers, and what exactly means then we will be discussing how exactly the communication will be happening, and what are the the protocols which will be used in the different layers. So those will be discussed. So let's go with the topics which will be covering. The first one is the OSI layer and the TCP model. So basically the OSI layer is nothing but the open system interconnection, and basically it is used to communicate any communication will be have need to be happen. So we use the OSI model. So basically that is the base means the protocol which need to be used to communicate between any systems. And then we will be discussing the difference between the OSI layer and the TCP/IP model. Then then the next one thing is the introduction to the TCP and the UDP. So basically TCP is nothing but a transmission control protocol, and the UDP is nothing but a user datagram protocol. So basically what exactly this protocol will be used, how while transferring the data or the communication between the both the computers. So we will be discussing those things on the in the TCP and the UDP part. And the next thing is we will be working on the evaluation. We will be discussing on the evolution of firewalls, and what exactly it is the firewall is, and what is the evolution from years and years. We will be discussing that. And then we will be discussing on the stateful firewall, what exactly the stateful firewall is, and what is the importance of that. Then we will be moving on to the application gateway and the proxies. So this is another security concept. So we will be discussing about that, and we will be discussing on the different vendors of the firewalls, like so we have a different vendors of the firewalls, like Cisco, Palo Alto, Checkpoint, Juniper, and more, a lot more vendors are there supporting the firewall technologies. Then the next generation firewall. So what exactly the next generation firewall is, and what is the new requirement for the firewalls? Like right, the trend is changing, and we need to know. As per the trend, we need to upgrade our systems, our firewalls, and what are the tactics and techniques they are using. So those things will be discussed in this slide, and then we will be discussing on the overview of the Palo Alto, and what specialty in the Palo Alto, and how what are the techniques they came into the market. So we will be discussing on the overview of Palo Alto. Then we will be uh, then I will be going through the identification technologies transform the firewall and the SP3 architecture. So this is the basic architecture which will be used by the Palo Alto. So we will be discussing more onto the SP3 architecture in the coming videos. And then who can learn the Palo Alto and is there any coding experience is required? So we will be discussing that in the final slide. Okay. So let's mainly focus onto the basic concepts. So as I told you, the OSI and the TCP/IP model, right? So basically, the OSI model is nothing but the open system interconnection. So basically, it is a standard over the network which need to be followed by any vendor to communicate between the system to system. So when I'm saying the system, the computer to computer or the network to network devices to network devices or anything. It's open system interconnection. The protocol or the parameters which need to be followed to develop any kind of product uh, uh, into the network communication part. So basically, OSI came with the concept of 7 layers. Like whenever the communication will be happening between the two systems. So it need to follow the OSI model. So the 7 layers of the OSI model is nothing but the application, presentation layer, session layer, transport layer, network layer, data link layer, and the physical layer. So every layer has its own functionality, and how the data will get transmitted from application to the physical, and when the data is sent to the other around, so how exactly it will convert the physical layer data to the application layer. So those things will means it has been defined by the OSI layer. So then how exactly the data transmission need to be done is defined on the OSI layer. So in the OSI layer, so let's go with the points. So OSI layer, it's like it defines the network communication used by the system, open to interconnection to communicate with the other system. So basically, it defines the set of protocols or the prototypes has been defined, uh, how the transmission need to be done between the one system to the other system. So basically, let's take an example, right? So telnet or basic protocol, right? The HTTP traffic. So everyone will in the Google. So we will be writing the google.com. So basically, when we write the google.com, so it uses the HTTP protocol. Okay. So HTTP is nothing but like it's a hypertext part, right? So whenever the user enters anything, so it's a human readable format. So that is nothing but the application part, like application layer part. Okay, then it will get means then the data will get transformed to the different layers, like as seen over here, the presentation layer. So then it will get translated and it will try to encrypt and decrypt the traffic as the computer can understand, and then it will get transmitted, right? So every layer has its own, as I said, it has its own its own functionalities. So the presentation layer, it will just encrypt and decrypt the data or compress the data, and then the next layer, the session layer, it will establish the connections like this API socket, APIs or the sockets. So it will transform the encrypted traffic into the sessions, and then the transport layer will divide the upstream data, whatever the text which we are entering, right? So the transport layer, it will convert that data into the packet, and then network layer will then forward to the data link layer. Data link layer is nothing but means basically the MAC address will be used to identify which system has been means which system the data has been sent. So that the data link layer will be used, and then the physical layer, actual that the transmission of the data will be taken place into the physical layer, like so any wires, right? So it will like for us it will be visible as a wires, but actual data transmission will be happening on those wires how exactly with the analog or the digital signals, with the digital signs. So basically those part will be defined, has been defined in the OSI layer. So why it has been said an OSI layer? So as it has a 7 layers and every layer has its own functionality, that is the reason why it has been defined as an OSI layers. And yeah, so then the let's go with the points. So the OSI layer reference model, so basically it's a international standardized network architecture. So as I told that any transmission has been done, so we will be using the OSI reference model, and it has been standardized by the international bodies. Uh, yeah, and basically it is used to communicate between the both the systems. So it has been defined how the traffic need to be sent, those things which has been defined. So it helps you to standardize the routers, yeah, routers, switches, firewalls, motherboards, and other hardware. So any vendor which they are defining, means they are creating any product, so they need to follow this OSI reference model, and which will be help in means communication between both the devices or both the systems. So this is the overall the OSI layer. Then there's another model which has been defined by the international body, which is called the TCP/IP model. So basically, it suppressed the first 3 layers as an application layer, and the transport layer, and the network layer, and the last 2 layers is suppressed as uh, the physical layer. Okay, so basically why it has been defined in this fashion, because it is easy to communicate mm, communicate compared to the OSI reference model. But again, that's a reference model. OSI is that a reference model. TCP/IP is an actual model which has been defined by the international bodies. Okay, so basically why TCP and IP? So basically TCP is nothing but a transmission control protocol. uh, yeah, and transmission control protocol, basically it used to transport the traffic, that transport the data, and where exactly it will get transported with the help of IP. So how, what is meant by IP? Internet protocol. So basically internet protocol, so it will transfer the traffic with the help of the IP address. So that is the reason why it is called as a TCP IP model, the TCP IP reference model. So which will be used to communicate between the systems. Yeah. So coming to the more into the TCP, right? So as I said, so TCP is the part of the network layer, sorry, transport layer. So here it will comes. Yeah, here it comes, the TCP IP transport layer. So basically, so whatever the data which is coming from the upstream, so the transport layer, it will means it will encapsulate the actual data, and um, it will means the headers will be added, and then the actual data transmission will be done. And uh, and uh, and again, so how exactly it will get identified which system this data is traffic is belongs to? So for that, so we do have the header, the TCP header, which will be encapsulated to your actual data. So what header will do? So it will identify which system the traffic has been came, and what is the source and what is the destination. So those things will be there, reside in the TCP header format. So this is the overall TCP header. So for any network engineer, TCP and UDP and IP is the heart. We need to know what exactly the TCP is, and what is the format, or what is the size of that for TCP, and what are the different parameters it has. Because without knowing that, it's very hard for the security engineer means to understand what exactly is happening in the communication. Okay, so basically like so these are the different parameters which will be used: the source port address, the destination port address, which is a 16-bit size, and the sequence number and the acknowledgement number, and we do have a different flags, the urgent, acknowledgement, push, reset, sin, and finish, and the window sizing. So whenever the communication need to be happen, so what is the size which the packet size which need to be sent to the other system, so which will be defined in the windows size, and the urgent pointer, if there is any traffic which need to be sent on urgent basis, so this urgent pointer will be used, and the urgent flag will be used. So these are the basic things which we need to we need to know about the TCP. And the checksum. The checksum is basically used for the flow and error control. So this is with the help of the checksum. So we will be means we will get to know whether the traffic has been the traffic has been received without any errors. So these are so each and every parameter, right, has its own identity. And this is the basic things which we need to mm, which we need to know about the TCP. Okay, so basically in any communication, right, so between both the sender and receiver, so it basically uses the three-way handshake. Like, let me explain in the lemon term, right? So whenever whenever we see any person, and if we want to greet that person, so we will say hi, and the other person will respond with anything like a hi and hello, right? And then the actual conversation will be taken between both the guys, right? So in the same way, in the systems also, right, both the systems, are the sender and the receiver systems, or the computers, so it will follow the TCP technology. Like, so basically, whenever the user sends any data to the remote system, so first the TCP will try to establish a connection between both the sender and the receiver, saying the first handshake will be like yeah, the first handshake will be like the TCP SYN with a synchronization set as 1. Yeah, you can see this is the flag which will be used. And the second, the acknowledgement from the other system will be sent SYN plus acknowledgement. This is the flag. So it will be used SYN plus ACK. That means the system is responded, and then the actual data transmission will be happening between the both the systems. The actual data transmission will be happening, so with the help of the higher level applications or protocols. So for any communication, as I said, for any communication, the initial setup, the TCP, SYN, and the actual data acknowledgement, the data transmission will be happening. And for the termination also, right? So when we say bye to the any user or any person, so we'll say bye, and we'll meet another time, right? So in the same fashion, so TCP is also, whenever whenever the connection want to terminate, so it will follow the four-way handshake, meaning, so the fin will send, FINAC will be sent by the receiver, and it will wait for the wait for the actual data transmission will be happening, and then as a receiver will send acknowledgement, and then the actual connection will get closed. So this is the four steps for the connection termination. So yeah, this is the basics of the TCP. And yeah, so if you see over here, so basically it used to process communication between both the computers, and it uses the port numbers to communicate both the sender and receiver. So it uses the port numbers. You can see over here the port address, the source port and the destination port. So destination ports means here port 80, telnet, or SQL, or any port, right? So it need to get the process need to get established between both the sender and receiver. And the TCP also uses the flow and error control mechanism. So how exactly the flow and error control will be done? So with the help of the window size, the flow control will be managed, and with the help of the checksum, the error control will will be used. So yeah, TCP uses the sliding window for flow control. That is the mechanism. Sliding window is the mechanism. And whereas the TCP uses the acknowledgement packet, timeout, and the retransmission. For the error control, if there is any error occur, means it checks on the checksum, and if it finds if there is any error, then it will try to resend the traffic. So basically TCP is the connection oriented. So basically, because so it follows the TC SYN, SYNAC, and the acknowledgement and the data transfer will be happen, right? So it makes first the connection get established, and then the actual connection actual data will get transferred. So by that it says that it's a reliable transport, means it makes sure that TCP makes sure that the data transmission happens perfectly without any errors, without any flow controls, flow control errors. So those things will make sure that the TCP will do that. Then comes with the okay. Then comes with the UDP, right? So why do we have the UDP? Okay, so when we have the TCP, why do we have the UDP? So UDP is nothing but a user datagram protocol. So basically this is a connectionless protocol and not reliable. So basically TCP is a more congested, like it uses the three-way handshake, right? Because of that it uses the most bandwidth of the network. So sometimes some of the application that is not required for any kind of audio or video, right? If there's any lag, if there's any a drop in the packet, so that's when we can means the actual transmission will be happening. So any kind of a realistic real time traffic, so we will be using the UDP protocol rather than the TCP, right? So yeah, that is the reason why we use the UDP. So as I say, it's a connection-less protocol, so it doesn't require the three-way handshake is required. So basically, it just means SYNAC will be there, but the actual data transfer will be there. But it for every data transmission, it won't look for the acknowledgement. So that is the reason why we that is the reason why it is called the connectionless protocol. So why UDP used even though it is unreliable, right? So it's a simple protocol with a minimum overheads. Like if you see the packet of the TCP, it has a number of things. Means is the header length, the TCP flags, and the window size, urgent pointer, checksum. So all these overheads are there, and for every communication, for every data transmission, it need to check all these things, right? But whereas in the UDP it doesn't require. So it means just check with what is the port number, what is the destination source port and destination port, what is the header length, what is the header length of this, and then it will check for any kind of error it has. The checksum will be there. So basically this the only means there's a minimum of overheads compared to the TCP. So useful in a process what to so basically this is basically used for the real-time traffic. So this is the major difference between the UDP, TCP and UDP. So just to go through it, and we do have the some protocols which supports the UDP, and some protocols which supports the TCP, and TCP is more complex and UDP is simple. Basically UDP used for the unicast and multicast, and whereas the TCP it's only unicast. So there's a lot of difference between the UDP and TCP, and depends upon our scenarios we'll be using which one means we will be selecting the protocol and the communication of both the systems. Yeah, then comes with the evolution of firewalls. So basically, what is firewall? So see, if you want to define me in a layman language, right? So whenever there's unknown person which he's try to enter into your apartment, so there's a security guard is there. There will be a security guard will be there, right? He will be try to authenticate who is that person, and is he means belongs to that apartment, or is any relative to that apartment. If he is a relative, he will call to the concerned apartment means apartment owner, and he will confirm, then only he will send it. So basically here the firewall is the security guy between the outsider and the apartment owners, right? So likewise in the network and security part. So the firewall is the main key role which will get which will allow you only the authorized traffic and it will block the unwanted traffic. Okay, so yeah, so if you see over here the points, right, the firewall provides the barrier between the network that prevent unwanted and unauthorized traffic. So basically, it drops the unwanted or unauthorized traffic. Okay, so basically, it came the technology emerged in 1980s, but why it has been emerged in 1980s? So basically, that's the initial days where the communication means the computer has been introduced into the network, and there's a lot of threats which is happening where there's no security controls. So basically, during that time, because of the security breaches, because of the threats, so the firewall technology has been used, and basically it prevented the traffic which is not required, unwanted traffic. So yeah, so there it comes the 1980s, the traffic, it has been introduced, the firewall concept has been introduced, and it initially came with the packet filtering, and then in 1990s it came with the technology of the technique called as stateful packet inspection. Then it came with the application gateway, and then it's adaptive proxies, and now it's a next generation firewalls as the technology is getting evolved, and there's a lot of threats which is happening over the internet. So accordingly, the firewalls need to be upgraded or need to be supported with the latest traffic, right? So that is the reason why the next generation firewall has been introduced, and we will be seeing more about the next generation firewalls in the next coming slides. So yeah, we will be discussing what is the packet filtering, stateful packet inspection, application gateway. So all these things we will be discussing in the coming slides. And then what is the next generation firewalls? So those things will be discussed in the coming slides. Yeah. So in the so in the packet filtering, right? So so when they introduced the means when the firewall technologies has been introduced, so it only used to check the few parameters, and then according to those parameters, if it is matching, if that criteria is matching, the traffic is getting allowed. So this is only five parameters which basically it is checking: the source IP address, destination IP address, protocol type, whether it's a TCP or UDP, source port and destination port. So only these five parameters which used to check in the packet filtering, and then it will try that traffic is getting allowed or dropped uh, by the firewall. But it doesn't stops over there, because it has means the inspection need to be done more aggressively. Then so that is the reason why the stateful inspection has been the concept has been introduced. So basically in the stateful inspection, right, so it uses the TCP means basically it establishes the TCP connection. So so basically in the connection table, the TCP connection table in the stateful inspection, so basically it will check the parameters of the all the like acknowledgement number, sequence number, and the window sizing. So all those parameters will be maintained by the firewall. Means this is stable, the whenever the new connection is getting established, so all these parameters will be there, and then the data transmission will be happening, and accordingly the threat will get prevented. Like if there is a new connection which is came and say and it is saying that I already entered into a network, let me allow, it will check whether it is there in the state table. If it is not, it will directly drop the traffic, if it's not a new connection. So this like as the network is getting evolved, there is a number of techniques, the threat techniques which has been used by the hackers and try to enter into the network. So that is the reason why the stateful inspection has been introduced. Basically it will maintain the connection entry, and it will check for those connection entries, and then the traffic will get allowed. So that's the main concept of the stateful packet inspection. So let's go with the points what we have written. So basically stateful inspection uses the same fundamentals of the packet filtering, right? In addition, it examines the packet header. So packet header in the sense whether it's a TCP or UDP, so it will examine that of the from the network layer, and then accordingly it will verify, and if it will check whether it's a legitimate or not, and then that it will then the traffic will get allowed. As the packet passes through the firewall, the packet header information is examined, fed into the dynamic state table where it is stored. The packets are compared to pre-configured rules or filters, and allow or deny decisions are made based upon the result of the comparison. So basically, as I said, right, so it will be using the stateful inspection table, and it will check whether need to be allowed or not. So those things will be defined, and accordingly the traffic will get allowed in the stateful firewall. Okay, and next come with the application gateway or proxies. So basically, what is the use of this? So why application gateway is required? So basically, in the packet filtering, only five tuples, five parameters which is getting examined, and in the stateful inspection, uh, apart from the five parameters, it is also maintaining the packet header of the TCP or the UDP, right? So the hacker are more intelligent that they are bypassing that, and trying to enter to the network, and the data is getting compromised. So because of that, so the application gateway has been introduced in 1990s, and basically what exactly it means. So the application gateway is performing as a man in middle. So what exactly it will do? So whenever the sender will try, means whenever the internal user is try to access the any external application, so in the packet filtering and stateful firewall, it will directly pass the traffic. But whereas in the application gateway, it will break the connection. What exactly it will do? From the user, internal user, to the application, there will be another one connection, and from the application firewall to the actual destination, the user where has been requested, there will be another connection. So these are two connections will be managed by the application gateway, so that it will inspect if there is any traffic is there, means any kind of malicious traffic is there in the packet, and then it will get accessed. So it's like it will unwrap the packet, it will check, and it will establish a new connection from the proxy saying that I am the user. Application firewall says that I am the user, and can you serve that application, so that website. So basically the hackers won't see what exactly the IP address of the end user. So basically it is hiding the user IP, actual original user IP, it is getting hides on the application gateway. So that is a technique which has been brought into the application gateway. And what is the use of it? Basically the first thing is it is hiding the IP address of the actual user. Second thing is it is unwrapping the packet, and it will check if there is any malicious traffic. And if there is any malicious traffic, then it will get the traffic will get dropped and at the application firewall itself. And depends means how exactly this malicious traffic will get checked. So it will be having its own database, and it will check with those database, and accordingly it will be get the traffic will get served. So basically it explains, this slide explains everything what I have been told, like yeah. So it plays the middleman. The application firewall plays as a middleman, and the application gateway acts as an intermediate between both the endpoints. Both the endpoints here in the sense the user, actual user, and the user is trying to access the application, the website. So the packet screening will be happening in this model, right? Yeah. So just go through this slide, so you will get to know more about what I have been told. Yeah. So the second thing is, yeah. So this slide explains about the different vendors of the firewall in the market. So right? So basically, the Cisco is the came with the networking concept, network and security concept, and so we do in the market, we do have different vendors of the firewalls like Cisco, Checkpoint, Palo Alto, Fortinet, Juniper. So in some instance, some vendor has been ruled the network the security infrastructure. So Cisco came with the initially came with the packet filtering concept. The checkpoint is came with the stateful inspection concept, and the Palo Alto, it has its own parameter, means additional features, and they came with the features of the firewall and came into the market. Fortinet, it's like they have their own concept of SD-WAN, and they came into the market with the additional threat intelligence, anti-malware, and UTM boxes. And the Juniper, they have their own identity of the SRX, and they came into the market and serving the network infrastructure. So there's a number of, not only this, there's a number of vendors which we have over the over the marketplace. So you just go through the each vendor, you will get to know what exactly and what are the service they are offering. Okay. Yeah. So here the next generation firewall concepts comes with. Okay, so basically what exactly the next generation firewall is, and what is the new requirement of the present generation of the firewall, right? So the basically the next generation firewall is nothing but it's like in the traditional firewalls, it provides the stateful inspection and the application filtering part. But in the latest the next generation firewall, it is more than that. So what exactly it is more than that? So basically it will be checking the data. It will check whether it has any malware. It will check whether it has any kind of virus. If there is any word attachment is there, it will check if there is any kind of any macros has been malfunctioning. So those things, everything will be checked by the next generation firewalls. It's not only like in the traditional, as we discussed, right? Basically it will check the source IP, destination IP, source port, destination port protocol, and the connection entry. But in the next generation firewall, from the endpoint till the enterprise, so it will check, it will unwrap the packet, and it will check what is the actual application which is being used, and is it any malicious application. So those things will be get identified in the next generation firewall with the help of the threat intelligence tools. If there is any latest zero-day attack is happening, it will check those part, and accordingly the traffic will get served. So let's see what exactly the next generation firewall in the definition way. So basically it need to identify the application regardless of the protocol and EVS attacks, right? So basically it need to identify the application, uh, not only the port number protocol, it need to be identify the application, and it need to also identify the users, so regardless of the IP address. So whether the IP is means so basically in the traditional it used to check with the IP address, whether the traffic is there or not, legitimate traffic or not. But in the next generation firewall, it need to check the users also, like whether what kind of user he is. He belongs to the HR, and he is allowed to access to which application. Those things will be the addition add-on feature in the next generation firewall. And it need to protect the real-time traffic against the threat embedded across the application, right? So any application, it has a number of malicious code, right? So basically the hacker try to inject some malicious code into the website and try to access, and if it is being allowed through the firewall, and it data would get compromised, right? So as a next generation firewall, we need to means it need to identify if there is what kind of injection is being used, whether it's a cross-site scripting or SQL injection. It need to be analyzed, and accordingly it need to take the action. So that is the add-on feature of the next generation firewalls. So it need to fine grade the visibility and policy control over the application. So yeah, so some of the applications like torrent is an application, so right, so whether that need to be allowed or not. So ideally any organization which will be blocked. So with the help of the traditional applications, traditional firewalls, can we block that? No, it's very hard. That is the reason why the next generation firewalls are coming with these techniques and tactics, right? So the multi-gigabit inline deployment and perform the regression, like so by identifying all these things, right? So all the 5 points which is there. So if the firewall is doing those things, so there's a lot of degradation part will be happening, the performance degradation part will be happening. So we need to rectify that, and we need to overcome those, and we need to serve the seamless traffic need to be flowed from the firewall. So that need to be also supported by the next generation firewall. So this is the means basic points, basic necessity of the next generation firewalls. So yeah, so let's see what Gartner is defining the next generation firewalls. So standard firewall capabilities like stateful inspection, as per the Gartner. So it says that the stateful inspection feature should be there. Integrated intrusion prevention, right? So intrusion prevention, like the layer 7 OSI reference model, right? The layer 7 application. So it need to be checked that application in and need to be allowed or not. So those features need to be allowed. Application awareness and control to see or block any apps, risky apps. So it need to check what is that application is it any means is the organization is allowing that application. If not, what exactly need to be done. So those things, the threat intelligence source, like if there is any zero-day attack is happening, so it has enough capability of threat intelligence to check and take the action accordingly. So upgrade the paths include the future information feeds if there is a new feature which need to be included. So they it need to be it should be having those controls also in the upgradation, right? So if there's a new feature has been introduced, so it need to be have a capability to support that feature. Techniques to address the evolving the security threats, right? Every day there's a lot of threats is happening, and it should have a technique to get identified and take the appropriate action. So this is the overall 6 points which the Gartner ideally means defining the next generation firewalls. So yeah, so this is what the Gartner is defining what is the next generation firewall and what it should ideally contain, must contain, to make and to define it as a next generation firewall. Yeah. So coming to the Palo Alto, right? So why the Palo Alto is basically came into the means is more popular in the internet. So basically, Palo Alto is a network security company. So they came with a concept of the app ID, user ID, and the content ID. So we will be discussing more about that. So this is which came into the market. This is the future futures of the fire of the Palo Alto. So they came with this concept, the app ID, user ID, and the content ID. And apart from these requirements, so they are using that. This is the new means the futures which has been identified and they have been deployed and they came into the market. So how exactly this helpful for the any security, any network the security part, right? So basically, the Palo Alto is a next generation firewall, gives this a security team complete visibility and control over the network using the powerful identification, malware prevention, and threat intelligence techniques. So this is the Gartner what is trying to say: identification, mal prevention, and threat intelligence techniques. Right. And apart from that, stateful inspection, which it has, and apart from that, the upgradation part, like it can accommodate the new threats or information which need to be feeds the threat feeds and the next upgrades. So as per the Gartner, so you can see where means the Palo Alto is the one of the leader in the market, which is there in the network security, especially into the firewall. So yeah, so as I said, right, Palo Alto came with the three innovation solutions. The first one is the app ID, second one is the user ID, and third one is the content ID. So what exactly those things are? So basically, these are the patents of the Palo Alto, the app ID, content ID, the user ID. So they came with these features. So basically, app ID is nothing but a so in today's world, there's a thousands of applications are there. So how exactly that will get identified, right? So take an example, torrent, how exactly the torrent will get communicated with the help of HTTP. HTTP is a protocol, right? And with the help of with the HTTP, the traffic is getting the torrent traffic is getting allowed. But any inside user will means see, as per the traditional firewalls, if we say it, any user can browse the internet, and that is the ideal requirement of the any organization. But uh, end user it uses means as per the protocol it uses the HTTP, but the application which is using is torrent. The communication is happening, and it's more threat to the organization. So Palo Alto came with an came with the concept of app ID. So for every application, they set up database, and they will giving the application means app ID for in every application. So with the help of that, so it will be defined whether the app need to be allowed or not. So it will be unwrap the application means unwrap the packet. Whenever the communication is happening, it will unwrap the packet. It will be identify what exactly the port is, what exactly the application is, and whether it is matching with the database. If it is not matching, it will make it as an unknown traffic, unknown application, and depends upon the uh, definition. The traffic means definition that the traffic will get either allowed or denied the traffic. So app ID is nothing. It's a let's go with the points, right? So app ID is nothing but it's a patent traffic classification system only available in the Palo Alto network firewall. Determines what an application is irrespective of the port, protocol, encryption, or any other EVS tactic used by the application. It applies multiple classification mechanism like application signatures, application protocol, decoding, heuristic algorithms to know what exactly the traffic is. So basically, it uses a number of tactics like application signature. What exactly the application signature is? The the way it is behaved, the application. So it will be defined. It will be identified that application. So like how exactly means what is the port number it is using, what is the database it means what way of communication basically it is using. So those things will get identified, and heuristic algorithms it will be applied, and then it will be identified what exactly that application is. So basically this is one of the future which has been introduced by the Palo Alto, and basically it will be defined what exactly the application is, and it will be helpful for user to block or allow that application over the firewall. And then user ID. So basically user ID is nothing but see any traditional firewalls it used to block the traffic with the help of the IP address. But is it what happens if there is any IP spoofing is happening, and it will try to allow means as per the traditional firewalls definition, the traffic will get allowed or denied, right? But here they are not going with the IP. They are also going with the user with the help of the user IDs, and which user need to means which user need to allow the which applications. So, like take an example, the finance. Any organization in finance is the more critical part, right? So like if they are trying to access any application which is malicious, and it will be major impact, right? So with the help of the user IDs, so we can define this what user to access which application. So those things will be defined, and accordingly we will be allow the traffic over the firewall. So basically, yeah, if you see the visibility protocol, policy control. So both with the help of the visibility and the policy control, we will be defining the security policy, and accordingly we will be either allowing the traffic or denying the traffic, right? The logging and how exactly it will be means with the help of the logging and reporting and forensics, so we can identify which user having that IP address, and those things will be defined. So let's go with the these points, right? The user ID enables you to identify all the user over the network using a variety of tactics to ensure that you can identify user or on all location using a variety of access method and operating systems. So knowing your user and or instead of just IP address. So basically it uses the visibility, it helps you to visibility and policy control. So how exactly the visibility, improved visibility into the application usage based on your user gives you more relevant picture of the network activity, right? So if the financial guy is trying to access more traffic, what kind of application he is trying to access and what is the use of it. So we will be analyzing that, and accordingly we will be place the the policy controls, the security controls. So how exactly that will be doing what is the network activity the user is using. So basically with the help of the logging reporting or the forensics, so we can define the rules. And comes with the another feature is content ID. So content ID, it gives you the real-time threat prevention engine combined with the comprehensive URL database element and the application identification. So basically it will check what exactly, so any traffic which is getting passed from the firewall, it will check, unwrap the data, and it will check the URL, and if it will check if there is any real-time traffic which is happening, then it will check, then accordingly it will either allow the traffic or drop the traffic. So that is the another major point of the content ID. So basically all these three concepts is more important if you are if you want to get into the Palo Alto. So the app ID, user ID, and the content ID. So basically these three are the plays the major role in working on the Palo Alto firewalls. So Palo Alto came with the architecture of the SP3. So what exactly the SP3? So SP3 is nothing but a single pass parallel processing. So it defines the SP3, single pass parallel processing. So what exactly it is? So in traditional firewalls, it used to check the access rules and it will get allowed. But in the next generation firewalls, it also need to check the antivirus, malware, vulnerability management, all these things. Uh, so how exactly it will check? With the help of the app ID, user ID, and content ID. So it will check and it will get passed from the firewall. So as I said, it's a single pass parallel processing, right? So in the single instance itself, all these security rules, as well as this next the layer 7 application identification will be get checked, and then it will get processed to the network. So yeah, this is what it says. What makes the Palo Alto network Palo Alto networks next generation firewall so different from the competitors? So basically, it uses the SP3 architecture. Palo Alto delivers all the next generation features using the single platform, parallel processing, single management system. So basically, it's a single platform having the parallel processing. Okay, so that is the main advantage to get into the the Palo Alto network. So basically, the Palo Alto next generation firewall main strength is single pass parallel processing architecture, which compromises of two components: single pass software, parallel processing hardware. So if you see this diagram, right? So over here, the parallel processing hardware is there. So it has the control plane and data plane. So this is the hardware part, and the software part is nothing but a policy engine, the app ID, user ID, and networking concept. So what exactly this will do? The policy engine, it will check the whether to allow the traffic or not. But apart from that, parallelly it will also check the application, user ID, content ID, and the networking, the routing part will be done over here. But how exactly this will be a lot of traffic which will be coming, and in the single pass itself, all these things need to be done. So because of that, so they are using the parallel processing hardware. So they are using the parallel hardware concept where it has the control plane and the data plane. So yeah, let's go with the points, right? So the first thing, single pass software perform the operations once per packet. which means which means so all the sorry which means all the user ID, the policies, application ID, decoding, signature matching, so all this will be done in the single pass itself, single pass software. So which means all this will be done over here. Okay, and the second thing is content scanning is also done. So once the packet is hitting the firewall, so as we discussed, the next generation firewall, it will check, it need to check if there is any the real-time threat is there or not. So it will be unwrap the packet and it will check for the content part whether which need to be allowed or not. So yeah, the second thing is content scanning will be done, and then it will get passed. Okay, so this is the nothing but a single pass software. And the second thing is parallel processing. So all this thing will be done with the help of the data plane and control plane, which is the core heart of the Palo Alto. So basically in the data plane, what exactly it will check? It will check the signature match. So basically it will check the IPS, any exploit, virus, spyware, and all this thing will be done by the data plane. And apart from that, security processing, in the sense, so we said, right, the IPsec VPN decompression, so those things. And the network processing means the flow control and the route, ARP, MAC. So those were the NAT part will be done, taken care by the data plane. Whereas in the control plane, so the management part, the configuration, the logging and the reporting will be taken care by the control plane. So with the help of these, with the two features, single pass software, parallel processing. Single pass, all the traffic will get scanned, content ID, all this will be done in this single pass software. But actual hardware, so this will be means in the data plan, the signature processing, the security processing, and the network processing will be done. And in the control plan, only the management, the logging and reporting and the configuration will be done, taken care from the control plan. So this is how it can be achieved, whether it's the gigabit of traffic also, right? So it will get achieved with the help of the SP3 architecture. So there will be a minimum latency and maximum throughput. So I hope you have the basic idea of what is network and what is Palo Alto and what is the SP3 architecture and why the Palo Alto, what are the features they came with the additional features they came into the market, right? So basically it's very interesting. So anyone can learn the Palo Alto, right? Not only the Palo Alto, anyone, if any engineer who want to mold the career into the network security, so this is the best choice. And the Palo Alto is very easy to understand. Very everyone think that it's very hard, but it's very easy to understand. But the basic things need to be having the knowledge like a TCP, UDP, and the actual protocols, right? So in any networking guy need to know those basics. And Palo Alto is very easy. So right? So if you check in the LinkedIn or the Naukri portal or the anywhere in the public job portals, right? So you just type the Palo Alto, you will get a number of MNCs which having the opportunities, and you can build your career in the right direction. It's not only infrastructure security, so you can once you get into the infrastructure, having the good number of years of experience, then you can move into the different technologies, the security technologies, where the penetration testing or the application testing or application tester, right, or the risk management or anything. So you can mold your career from there. So this is the starting point of the starting point of means if you want to go with the more, or if you want to mold to the network security, so I think this is a better opportunity where you can learn the good means how exactly the packet is getting flowed, what is the risk associated with the TCP, means each and every granular level you can check that, and you can understand that, and you can make your path into the security world. So does the Palo Alto require any coding? No, absolutely not. But if you have, that will be a really added advantage. But it doesn't require anything. So yeah, so we will be coming more slides or more videos into the um, next videos on the Palo Alto, and keep subscribed in SecApps, and do drop us do drop us if you have any questions. Thank you. Thanks all.